Hello students, welcome to Lab 11. Today we're going to clean up some odds and ends and some loose ends that are left over, things that we may not have covered yet in our Python exploration, but concepts that are generally applicable to both R and Python. We're also going to start off today by talking about Github, which is one of the tools that you'll almost certainly use or some version of it in your career if you choose to be an analyst or a data scientist that does any amount of coding. Hopefully, as we near the end of this class, I'm sure you'll need a little bit of a break from the kind of intensity of the course and how quickly you've learned everything. But once you recover from this class, hopefully you'll find that actually you do enjoy doing this type of coding a little bit, and I hope you'll keep up with it. When you do, you may find that you need some sort of tool that keeps track of all of the different versions of your code that you have developed. And you need some way to robustly share it with other people who may want to review it, who may want to use that code, and you may want to collaborate with in general. If you work in a data science or an analytics department that does a lot of coding, you'll either use GitHub or Bitbucket or some other version of version control to control when you know your project is done. You need to get approval, usually, from your technical lead or from your manager or someone else who will basically give you a thumbs up. And GitHub, generally speaking, is the way that we do that. GitHub integrates. So today we're going to talk about what GitHub is and the very, very basics of how to use it. That's how we're going to start off. And then we're going to go back into Python and we're going to do a little bit of cleanup. We haven't really discussed how to do if-else in Python, so we'll briefly discuss the NumPy function where, which is basically just if-else, so we won't take too long to do that. We'll also talk briefly about list comprehension, which is just a fancy way of saying a tidy for loop, or a for loop that's a little bit easier to work with. If this is your first time learning about for loops, which I suspect it might be for a lot of you, then list comprehension is really just a different way of thinking about for loops, and it returns a list rather than returning individual elements. So it can be very useful when you want to do things across an entire array, for example, a NumPy array or a list. Likewise, we're going to talk about other forms of iteration. It's not always the case that we know before writing our loop how many iterations we want to go for. For example, if I have a list and I know how many elements are in the list, well then in that case list comprehension or a for loop is really perfect because I know I just want you to iterate over as many elements are in the list. But that's not always the case. Sometimes I want to iterate until some condition is met, and the number of iterations that are required may be different from case to case. So we'll talk about how to accomplish that with a while loop. And lastly, we'll briefly dip our toes into recursion. You probably won't use recursion a lot, and the use cases that we use it in are going to kind of be limited, but it's important that you get exposed to it anyways, just so that you can have an extra tool in your toolbox. Before we jump into Git, one of the things I want to talk about is why don't we spend more time doing for loops, list comprehension, while, and recursion? Surely these are kind of core concepts of programming. Wouldn't it be helpful to have a lot more time spent on them? I would say, in part, that is correct. For loops, list comprehension, while loops, and recursion are definitely very important parts of computer science and programming that it's very helpful to understand. However, this class in particular is really a focus on the tools that you need to succeed as a data analyst. And the thing is, most of the functions that you need can be far more efficiently and more easily and more readably accomplished using vectorized code. When I say vectorized, what I mean is we're not explicitly writing for loops. We allow the tools that we use to do our for loops for us kind of behind the scenes. So what do I mean by that? Well, when we did our dplyr code, we basically didn't write any for loops at all, even though at the bottom of all of that code, there were for loops. When you think about what mutate does, it just goes row by row, and it does the thing that you asked it to do. You didn't have to write that for loop. Mutate, the function, is written such that R can accomplish that on the back end much more efficiently than you could write a for loop. Likewise with while and recursion and list comprehension, which is really just a different way of doing for loops. Yes, it's very helpful and useful to know how to use these tools, but if you find yourself relying on for loops a lot in your analysis, something has gone wrong. So generally speaking, you want to stay away from for loops. There are some scenarios where they're necessary, but for the most part, we don't want to be using these tools as the primary tools to do our data analysis. And that's what this class is about, programming for data analysis. So let's get started on GitHub. You've probably heard of GitHub. And one of the tools that makes using GitHub much easier is GitHub Desktop. So I'm not going to teach you how to use the CLI, or the command line interface, which is, actually, why don't I just open it up and show you? The command prompt here, right? You've probably seen this in your console in R, for example. All the hackers and movies that you watched use this because they're cool kids. But it's a huge pain in the rear to kind of interface with any of your tools using this. Frankly, most of us who are not computer scientists or didn't go to school for CS are much more comfortable using a graphic interface, and that's what GitHub Desktop does. So go ahead and download GitHub Desktop. And while I'm doing it, why don't we go ahead and open up Visual Studio Code while that's being installed. So let's go ahead and, of course, as always, do a new file. And we want a Jupyter notebook. And we're going to save as in lab 11, I believe. Yes, lab 11. And we're going to call this lab 11. Okay, here's what GitHub Desktop looks for. You'll notice I use GitHub, so there's already a project that I've created. But let's forget about that for a second. Instead, why don't we create a new GitHub project? By the way, mine is already connected, even though I downloaded it, because I have some saved cookies and config files on my computer. But you're going to have to log into your GitHub account when you do this. So go ahead and feel free to pause this and make a GitHub account if you don't already have one. And if you do already have one, you just have to connect GitHub Desktop to your GitHub account so it can do all of its actions from right here. So why don't we? So go ahead and pause and do that. And when you're back, we're going to add our folder to our GitHub repository. So what do I mean by that? Let's go ahead and log in to my GitHub account. Let me pause here for a second. I'll log in, and when we come back, we'll be in my GitHub account, and I'll show you around, see what it looks like. Alrighty, we're back. Here we are in my GitHub account, and you'll notice this word repositories. This is really what you're interested in looking at. A repository is basically just a folder that contains a project. That's it. It's just a folder that contains a project. The most recent project that I've been working on is a paper for a political science conference. One of the things that Git and GitHub do, by the way, Git is the underlying technology. GitHub is kind of like a way to implement that technology. But I'm going to talk about just GitHub so as not to muddle this conversation too much. One of the things that GitHub does is it keeps track of all of my files and all of the changes that I've made to those files in this project over time. Why might this be useful? For one obvious solution is sometimes I make a mistake and I want to go back to a previous version of a file that I had earlier. Now I don't need to use GitHub to do this, of course. I could, in my folder, just have a different file that has at the end of the file name a different date. Let's say I work on my paper every single day. When I'm done for the day, I'll just go into my file, my draft.odt, and I'll just append to the end of that. It'll be like, what's today's date? August 21st. It'll say draft 082125, and then tomorrow it'll say 082225. That gets cumbersome pretty quickly. And more importantly, if I'm working with other people on that, our drafts eventually are going to diverge. And we need some principled way of not only collaborating off of the same folder, but of resolving those conflicts when they arise. And this is one thing that GitHub is really good at. You can think of GitHub as kind of, in one sense, it's cloud storage for your projects that other people can collaborate on. So you'll notice that up here it says 25 commits. Now sometimes I make a lot of commits, some days I make less commits, but every one of these commits, you can think of them as a time that I hit the save button. And I said, yeah, I finished this part. Go ahead and upload my progress to GitHub. If I wanted to roll back to any of these checkpoints, these saves, I could do that very easily. I'm not going to show you how to do that now because it's not too important, but generally speaking, you could, right? So it has basically saved all of my commits. We just created a new file. So why don't we go ahead and create that in GitHub? You'll notice that I don't have a repository called week 11. So I'm going to go ahead and I'm going to add a repository from that folder called week 11. So let's go into GitHub desktop. I'm going to say add, and I'll be honest with you, I always forget if it's create a new repository or add an existing repository, but I'm pretty sure it's create new. So I'm going to choose a new one. We're going to say lab 11. We're going to select that. I'm going to say, let's name this, and we're going to say lab 11. Actually, I want to make it on my desktop. I'm going to say that. It's going to be called lab 11. It's going to create a new folder, and I'm going to say files associated with programming for analytics lab 11. I'm going to create that repository. You'll notice that all of a sudden it says there's a button here that says publish repository, but there's nothing in this folder quite yet. Let's go to my desktop and let's see where it created that folder. Is this it? It sure is. There we go. So it created this folder called lab 11, and I want to publish this repository. Right now, this is just a folder that exists on my desktop. It does not live in GitHub yet. So let's go ahead and publish that. Yep, I don't really need to change that. And I want to keep this code private. It's just for me. Right, let's publish that. And it's pushing all of these files that are in this folder, is pushing those to GitHub. So why don't we go ahead and take a look at GitHub, and let's see what happens. Suddenly, lab 11 exists. Not only does it exist, but it has the notebook that I created. It has my data that I created, and a Git attributes file that is not important for our sake right now, right? So terrific. What we've done is we've created a repository here on GitHub. If I wanted to invite collaborators to this, I would go into the repository. I would go into settings. I would go to collaborators, and then I could invite people via the email or however else I wanted to, right? If you choose to work on big projects, this is how you would do it. So that's what GitHub is in general, right? We've talked about commits. You can think of them as a save file. And in fact, why don't we make a commit right now? So let's go back to our code. I'm going to say import numpy as np, import pandas as pd, from plot9 import star. We're going to run that. We're going to see if it runs. Yep. And we're going to load our trusty diamonds data set. We're going to take a look at it. Yep, all that looks good. I'm going to hit save. And when I do, you'll notice that something changed here. Something changed here. It notices that I modified this file. And that's correct. It is saved locally on my computer, but the file on GitHub has not yet changed. So I'm going to say, let's commit this change. Let's say load libraries and data. Most of the time when you commit, you want to make a little bit more, substantial commits than just this. But for our purposes as an example, this will do. I don't really need a description here. The title is good enough. So I'm going to commit, and then I'm going to push. And push just means send it to the GitHub website. So you'll see 2 minutes ago. And if I refresh, just now I made a change to this file. And now I have 2 commits here. One for my initial commit a couple of minutes ago, and the commit that we just made. All of this has just been changed. So now we know what a commit is. It's basically a save that you make to the GitHub website, let's call it. The next thing that we should talk about is a branch. Sometimes you want to go exploring and you want to make significant changes to your code without it impacting the existing status of the code. So you want other people to be able to continue working on the code as it is, but maybe you have an idea for a new feature and you want to be able to work on that without disrupting other people. Well, what we can do is we can branch off of this code. So let's go ahead and let's do that. Right? So we can say current branch, I want to create a new branch, and it's going to be called analysis. Let's create a new branch. Let's go ahead and do that, and let's publish our branch. And it'll say, do you want to preview a pull request? All a pull request basically is it's an open request that says, hey, I want to merge these changes with the main branch. So think of a tree. We started off with a trunk, we branched off, and eventually after we're done developing our changes, we want to merge back into the branch. So no, not exactly like a tree. I don't know a lot of trees that work like that, but I think you're getting the visual, hopefully, right? Once we're done developing on our own isolated little path, we want to join back up with everybody else, and we want to do that. So let's go ahead and let's create a pull request. And there are no changes yet, so we can't create a pull request. So why don't we continue developing on this branch, and when we make some changes, then we can create a pull request. So let's say data.head, that's what I'm interested in. And in fact, one of the things that I want, why don't we look at np where while we're here? So we talked about branches. We'll finish talking about pull requests in a second. Let's talk about np where. So in R, we made very liberal use of the if-else function. And we need some sort of function. It would be helpful to have a sort of function that does the same thing in pandas or in Python. So let's say, real quick, I want to know the difference between a large and a small diamond. And so I just want to see what the distribution of diamonds is real quick. And so we're going to do the classic histogram of caret. And I just want to see what that looks like. So I can decide what a reasonable value cutoff is for large and small diamonds. And I remember it being kind of like this exponentially decaying function. I want to know what a good cutoff for a large diamond is. It looks to me that anything above 1 or 2 carats, why don't we call it 1.5 carats here, right? Anything above 1.5 carats, I would say, is a large diamond. Anything smaller than that is a small diamond, right? So if we look at our data set, I want a new column called large, and it'll take on the value, takes the value of large if it's a big diamond and small otherwise. So I know that this is what I want to call my new column, but in the meantime we're going to use numpy where. Where is the equivalent of if else in R. So all we have to do is we have to treat it basically the same way. We're going to say if data caret is greater than 1.5, then return large, otherwise return small. And when we get that, sure enough, we see that it's returning small for all of them. So why don't we go ahead and assign this to a new column. And when we take a look at data, we're going to see, okay, I see all small, but why don't I try and filter that to see if it actually worked or if it's returning small for everything. So I want to look at the caret column, and I'm going to say only return columns where caret is greater than 1.5. Yep, that looks good. And sure enough, we get large too, right? So this seems to have worked. It seems like we did a good job. So npwhere is the function that you want to use if you're doing if-else statements. So I'm going to save that. I'm going to say we did npwhere. And now let's look at our GitHub, right? So I'm going to say where function. And I'm going to commit this. And I'm going to push it. And when it's done, it's going to say, do you want to make a pull request? And now it'll allow me to make a pull request because my branch is different from the main branch. And it's saying, when you're done, where do you want to put all this new code? I'm going to say, I want to put it in main because that's the main branch that we're all going to work off of. So let me create my pull request. And it's automatically going to open it up. And it's helpful to have a little description here so people who are reviewing your code know what they're looking at. But for now, I'll just leave this alone. And I'm going to create a pull request. Now you'll notice that the pull request tab on GitHub suddenly opened up. Now there are automatic checks that GitHub does for you. You know, is your branch going to merge without a problem back into main? And it'll probably tell us, yeah, it'll be fine. It might run some other automatic checks like, you know, your code is looking a little goofy, maybe fix it. There are also, you know, you can ask Copilot to review your code if you find it, you know, and it's an LLM basically that's pretty good at coding that'll help you identify where your code or where your naming conventions may be inadvisable, and it'll tell you that. So this is where we would look over our code, where you would get your code reviewed by your lead or by your manager, and you would add reviewers here. Sometimes they'd be automatically added depending on where you work. That's the case where I work, for example. I get added on everyone who reports to me all of their pull requests. And when I look through their code, when I go here and I said, yep, why don't we go ahead and view this? When I look at it, all of our code shows up. This is the notebook that we just saved and that we pushed to GitHub. And I'm going to say, yeah, okay, cool. Yes, you showed me head. Yeah, okay, I get it. You're looking for a cutoff for a large diamond, and then you implemented. Looks good to me. Go ahead and merge it. I'm going to hit approve. And then once they have enough approvals, you can merge it back into main. And all that means is I'm going to take all of these changes and I'm going to apply them to the main branch. So that's what pull requests are. So let's review here for a second. I'm not going to merge this. I'm just going to leave this open for now because it's not really all that important. But when you're working on any project, really, it's helpful to start a GitHub repository. A repository is just a folder that contains one project. Now, the definition of one project differs from how much stuff conceptually you want to put together. But generally speaking, whatever one project means to you, that's what that's what one repository should be. A commit is basically like you saving your changes and pushing them to GitHub. Think of this as another place where you can save a file. Once you hit save on your IPy notebook in here, that saves it locally, meaning on your computer. Those changes are saved on your computer. But you now additionally need to commit those changes to your GitHub repository, right? Now, the reason those two things aren't exactly the same is that I'm just habitually hitting Control S and saving all the time, right? Between every 3 lines of code that I write. I don't want to make commits that often. I want to make commits when I basically have one idea done. An idea doesn't have to be that big, but I kind of want to be done with an idea before I push it. So, you know, make one visualization, learn how to do one thing. Those are commit-worthy code changes. Whereas if this isn't really working yet, I don't want to commit that. So that's what a commit is. It's like a save. A branch is a snapshot of the existing status of your code that you then build off of without disturbing the main trunk of your code. This is very helpful when you're working on an existing project. And for example, many of your first projects will probably be something like, hey, go into an existing project and just clean it up, make it a little bit better, see if you can find any improvements. Those are really a lot of the intro types of projects that you might work on as a data scientist. So when you get in there, there's already an existing repository. They don't want you committing to main, the main branch, because, for example, that branch is used to serve recommendations to existing e-commerce customers. For example, like all the customers that come to your website, they get served with recommendations, and those recommendations are pulled from the model that is in the main branch. So they don't want you fiddling around in there, but they say, go ahead and make a branch and work on that. So a branch keeps your changes isolated until they are reviewed and approved, and then at that point your changes get merged back into the main branch. The last thing is a pull request. And a pull request is a request for other people to take a look at all the code you've written and to give you a thumbs up to say, yep, this looks good. Feel free to merge this into the main branch. When you do that, your branch will disappear. It's not a bad thing because all of your changes are now included in the main trunk of your code. So really, all of your development in general starts with create a repository, create a branch, develop on the branch, get a pull request, get your pull request approved, and then merge back into the main branch. These are really the three main things that you need to know. So let's get back into the code here for a second. We've already talked about where, which helps you to do if-else type statements. Let's go back and let's talk about list comprehension here for a second. So for loops look like this. Why don't we create an array, and it's going to be called integer array, or I'm sorry, integer list. And we're going to say range from 1 to 10. And all range does, our equivalent is 1 through 10. That's it. That's all range does. So let's take a look at integer list. Okie doke. Let's say I want to take each one of these elements and I want to multiply them by 10. Now, obviously we would not really do this using for loops, but let's say I forced you to use a for loop. You might do something like this. For I in integer list, colon, enter, print I times 10. And let's run that. Notice that every single, first of all, that worked clearly, right? It went from 1 to 10, not inclusive. By the way, range is not inclusive. It went from 1 to 9, and it multiplied those numbers by 10. But notice that the output is basically a separate output. There's a line break in between each one of these, right? So it's not particularly useful for putting back into a data set, right? What we really want is we want a list out. Now, one way to do that would be to say, let's create a list to begin with. So this is an empty list. And I'm going to say, I want you to append whatever this outcome is, append it, and then let's see what holder looks like. So that's one way of doing this, right? But we have to manually append our output. We have to create a holder, right? So we might say, there's an easier way to do this. And it's called list comprehension. And it does the same thing as a for loop. Whenever we want to do list comprehension, as the name would imply, we start with a list, which is a square bracket. And rather than doing our operation last, we tell it what the operation is first. So we say I times 10, and then we go through our iterator for I in integer list. There are a couple of benefits to doing things this way. The first benefit is that it automatically puts all of my output into a list pretty efficiently. I don't have to go and do all of this appending nonsense. It just does it like this. The second benefit is that if you're new to for loops, this pattern may not yet be ingrained in the wrinkliest part of your brain yet, which in your case is a good thing, because it means that this is just as familiar as this is, and this takes a lot less code. More importantly, it puts the operation at the beginning of your code. And that's really what I'm interested in, right? Of course, what it's looping over is really important and interesting to know too, but in a sense that's secondary to what it is that you're doing. So list comprehension is basically just another way of writing a for loop. Now we can write ever more complex for loops. We might, for example, use if-else statements in here too, but I leave that for you to discover. For now, this should suffice for anything that you need. So that's list comprehension. It's just a different way of doing for loops. However, it's not always the case that we know exactly how many iterations we need, or maybe we don't have an item over which we want to iterate. We just want to keep going until we hit some condition. For that, we can use while loops. When it comes to a while loop, we need a couple of extra things. So for example, let's say I want to go until I hit 20 iterations, or until I hit the integer 20. So let's say we're going to need an iterator object, and I'm going to start off with my iterator being 0. And I'm going to say while iterator is less than 10, same kind of syntax as a for loop, right? But rather than saying for I in XYZ, all I'm saying is while iterator is less than 10. When it starts, of course it's less than 10 because our object is set to 0. I'm going to say iterator equals whatever its current status is plus 1. And then I want you to print what that is. So let's run that and see what we get. Great. And if I change that to 100, it goes all the way out until 100. Some tasks, few, but some tasks will take this structure. And that's basically for you to say, keep going until you hit some condition. I'm showing you a condition that is pretty trivial. You could just as easily do this sort of thing and say for I in 1 to 100, print I, right? But not all tasks take this structure. So when you need to do this sort of thing, and you don't know how many iterations you need, but you know that once you hit a condition you want to stop, use the while loop. It's done with while. The last type of exotic programming structure is called recursion. And this is a type of structure that calls itself. It's a function that calls itself. So functions that call themselves are recursive. Let's think of a mathematical operator called factorial. I don't think factorial is. Nope, factorial is not in Python, right? Maybe it's nope. It's also it's also not a NumPy function. That's fine. I'm sure it's called something else. Factorial. If you say factorial 5, all that means is I want you to take 5 times 4 times 3 times 2 times 1. I want you to keep going down until you hit 1, And then once you hit 1, I want you to stop, right? It's difficult to think about how we would program this using a for loop, right? So first off, why don't we create a function? And when we create a function in Python, it's going to be called define a function called factorial. And I'm going to tell it that it's going to take some integer. That's it. And then I'm going to say colon. And then I'm going to define what happens here. Let's go back and let's think about what factorial does. There's really two cases. If your integer is equal to 1, then you return 1. Otherwise, otherwise what? How is factorial working? It's not your integer times your integer minus 1. For example, if I were to say, what's factorial? What's 7 factorial? Your answer wouldn't be 7 times 6. It would be 7 times 6 times 5 times 4 times 3 times 2 times 1. You want all of the numbers that go downwards, right? So I want to return. Actually, I don't remember if return. I think return looks like this. Who knows? Let's stick with this and let's see if it works. Return, I want to return my integer times factorial integer minus 1. So let's conceptually run some numbers through this. Let's say I give you 1. It'll say, okay, does it equal 1? Yes. Then return 1. If I say 2, it'll say, is it equal to 1? No. So do 2 times, start the loop over. 2 minus 1 is 1. Is it 1? Yes. So it's going to multiply times that. If I put in 3, it's going to go through that loop twice. And it's going to continue to return 1 minus that number until it hits 1. So let's go ahead and let's try out our recursive function. So what's factorial 1? It is 1. Factorial 2 is also 2. And here's where it gets exciting. Factorial 3 is 6, right? 3 times 2 times 1. Factorial 4 is 24. 4 times 3, which is 12, times 2, which is 24. And I'm going to stop doing these out loud, but you can basically check, right? There are, again, not that many situations where you might use recursion, but they do come up. For example, at work recently, I had a data set that included a lot of people and their bosses. Let's say they were salespeople. Some bosses are also salespeople themselves. I wanted to group all people who report to the highest level salesperson boss. For some people, they report directly to one person, and then that person's boss is like a vice president, so they're not a salesperson. So it would only have one level. I would just look up that person's boss and I would be done there. Some people have like 5 levels of bosses between them and a vice president. So for example, there'd be a salesperson who would report to a salesperson manager, who would report to a salesperson director, who would report to a salesperson senior director, and then that person would report to a non-salesperson vice president. I want that senior director, the last link in that salesperson chain. I don't know how many rows deep each individual person's highest level boss is, but I know that everyone's boss is displayed in a from-to relationship. If I know who you are, I know who your boss is, and then I just follow that link, right? I go and I find your boss in the data set, and I look to see who their boss is until I hit someone who I know is a VP. In that case, I wrote code that looks very similar to this to use recursion to go through all of those salespeople list and get their highest level salesperson boss, right? So you won't use it very often, probably. I hope not. But when you do, you'll find that it saves you a remarkable amount of time. So, whoops. Let's see, what have we covered today? So, as we wrap up our lab, we covered a couple of things, right? So let me go ahead and save this. And I'm going to commit loops and recursion. I'm going to commit this to my branch. I'm going to push it. And now my pull request has this new commit displayed as well, right? So we did very simple things today. We loaded our good old trusty Diamonds dataset. We learned about GitHub. We learned about npwhere, which is basically just if-else, but for Python. Then we talked about list comprehension, which is essentially just a for loop, but in a different format. And it takes care of some of the more cumbersome aspects of a for loop, like appending your output to a list. And lastly, we talked about while loops and recursion, which are more fringe cases that you probably won't use very often, but it's helpful to know how they work. So as we come to an end in this class for you graduate students, I've probably talked about this in Lab 8 for undergrads, but now you're entering the end of your class. You have a lot of the tools that you need to teach yourself how to get better. Unfortunately, if you wanted to become a really, really good programmer, if your skill and your interest was in becoming an outstanding programmer, then this wasn't necessarily the class for you, right? If you're really interested in software development, we didn't really go too deep into the tools that would help you do that. These are the types of tools that would help you do that. What we did instead is we had a deep focus on the tools that you would need, those foundational tools that you need to do data analysis in Python or R, and have the flexibility to do it in either. That's important. As I mentioned when we first started in Python, it's really important that you consistently grow the set of tools that you're familiar with, rather than picking one and being dogmatic about it. The more flexible you are in your career, the easier you will find it to learn new things. Now, truth be told, learning new things is painful. I started out using almost exclusively R because my first job was an R workplace. When I moved into private sector, I had to learn Python from the ground up. Although, to be honest to you, learning Python was a lot easier, having already gotten pretty good at R. The syntax is pretty close. And while it wasn't pleasant, it wasn't as painful as learning R for the first time. Likewise, when I had to learn my second and third and fourth set of big new tools that I needed for my job, every time that learning curve got a little shallower, it wasn't as hard. And soon enough, when I looked back, I had learned a lot of things, and I realized that I was qualified for a lot of different jobs, and my skill set had expanded very quickly. At the same time, that I was getting deeper understanding of the tools that I already knew. Learning Python made me a better R programmer, right? Learning SQL made me a better R and Python programmer. It helped me to understand data structures. It helped me to work faster and more efficiently. So if you take nothing else from these labs, if you found yourself struggling throughout, that's totally fine. Programming is not an easy thing to learn. But I would say keep at it. Keep going. Little by little, every single day, if you keep at it, if you keep trying to solve a problem, you'll be shocked how at the end of a couple of weeks, you're remarkably more competent in any of these tools than you ever thought you might be. I believe in you. I'm sure that you can accomplish it. And so I hope you keep at it even after this class. I've had a great time teaching this course. I hope you have too. As always, if you have any questions, please don't hesitate to reach out, and I'll see you in class.